Welcome back to the deep dive. Today we are going to unpack something that on the surface seems completely routine, maybe even boring,
hmm
but it holds this massive financial, operational, and, well, engineering complexity just hidden beneath the surface.
We're diving into the essential guts of heavy industry. We're talking about lubrication.
Exactly. Specifically, bulk industrial grease. We've synthesized sources looking at Lubriplate products and their distribution through PE Energy to answer what seems like a simple question.
Seems simple.
Right. And our mission for you today is to, well, permanently shift how you see this. We want to take industrial lubrication, that seemingly trivial line item expense, and show you that it is, in fact, a fundamental part of profit retention.
Critical profit retention, safety compliance, and just highly effective preventative engineering.
Yes, you are not buying grease. You are buying mechanical longevity.
And this shift in perspective is so necessary because the cost of getting it wrong it's just staggering. It's hard to visualize until you really see the numbers. The sources highlight this perfectly. Imagine a manufacturing floor, and a surprise shutdown happens because of a lubrication failure. Or worse, a machine failure that scours a $1,000 bearing in a matter of minutes.
Or that specific example from the source material, which I found fascinating. A conveyor system that starts dragging 30% more amps than it should,
Yeah.
all because someone used the wrong grade of grease or, just skimped on how much they put in. How does sticky grease cause a 30% energy spike?
Well, it's purely physics, and it's a killer for the budget. When that lubricant film fails, you suddenly introduce massive friction,
Okay.
and that friction is converted directly into heat. The machine has to work exponentially harder just to overcome that resistance.
So the 30% amp draw is just wasted electricity.
Wasted electricity, and it generates all this extra heat, which then shortens the lifespan of literally every component around that bearing.
Yeah.
The seals, the shafts, the motors themselves.
So it's a compounding financial catastrophe.
Exactly. That single oversight, choosing the wrong grease,
Yeah.
it just cascades. So now you're paying for operator overtime to fix it.
Right.
You're paying for lost throughput while the line's down, you're paying expedited freight for the new parts, and you're paying a higher electrical bill the whole time.
Wow.
So on the flip side, the successful outcome, the machine that just runs quietly and efficiently for months on end, that's not some feel-good story.
Yeah.
The sources define that as predictable profit retention.
That's the bar. That's the high bar we have to apply to every one of these seemingly basic industrial purchases.
That's the bar.
So, okay, let's move past the failure scenario and talk about success. If the right lubricant is the key here, we have to talk about the engineering. I mean, professionals aren't just looking for slippery stuff. Right?
No, not at all. They are specifying precise chemistry, formulations designed to handle incredible stress, incredible temperature, and really harsh environments.
And this is where we get into the engineering of it all, the consistency and the versatility.
Yeah, and what's fascinating here is the core reliability. You see, industrial-grade products like the Lubriplate line and our sources, they become industry staples because they deliver on three things that are just non-negotiable.
Okay, what are they?
Reliable consistency, first, then specialized engineered formulations, and finally, broad application coverage.
Reliable consistency.
That seems a little obvious, but what does it actually mean in practice? I mean, doesn't all grease kind of feel the same?
Oh, not at all. Not even close. We have to talk about NLGI grades. This is the critical measure of consistency. You can think of it as thickness.
Okay.
So NLGI number 2, which is, let's say, roughly the consistency of peanut butter, that's the industry standard for general manual applications.
Got it.
But if you have an automated lubrication system, one that needs the grease to flow through these long, narrow lines, you absolutely need a thinner product, maybe an NLGI number 1 or even a number 0.
So if you try to push that peanut butter consistency through a system designed for something thinner, you're in big trouble. You can blow the seals or you can clog the dispenser entirely. The system fails before the bearing even gets a drop of lubricant.
So getting the grade wrong means the whole automated system is useless.
Precisely. And then you have the environmental versatility. You just cannot put the same product on a heavy load industrial bearing running hot in, say, a steel mill.
Right.
That you put into a food processing plant where incidental contact with the product is a real possibility.
That's a huge distinction. The actual chemical makeup has to change entirely for food compliance.
It absolutely must. For the food industry, compliance is everything. The sources mention specific lithium-based greases like the number 630 AAA
And why those specifically?
The reason is that they use non-toxic base materials and thickeners. That makes them suitable for incidental food contact, so they meet these very strict FDA guidelines.
So if we connect this to the bigger picture, the benefit of having a versatile product line is its simplification, isn't it?
It's all about simplification. A business doesn't need 24 different products from a dozen different manufacturers.
You can just consolidate your inventory around proven chemistries designed for your specific high-stress environments.
And that consolidation simplifies training. It reduces the risk of human error. It also ties directly back to how you apply it. I mean, look at controlled dispensing. The sources highlight the number 930-A, which is an NLGI #1 lubricant, as being ideal for automatic grease dispensers and pressure guns.
So you're matching the formula to the tool.
You have to. It removes the guesswork, and it ensures the right amount is applied every time. That reduces waste and cuts down on labor time on the floor.
Okay, that discussion about simplifying the toolbox leads us perfectly into the next piece of this, the procurement puzzle.
Yes.
Once engineering specifies the exact SKU, how do procurement managers and ops people actually implement this efficiently? Because they don't just need the chemistry, they need specs, they need compliance, and they need a supply chain that actually works.
This is where the logistics of wholesale sourcing, through suppliers like PE Energy, become this critical and often invisible link to profitability.
Invisible is a good word for it.
It is. We often just focus on the unit cost of the grease, but the sources really force us to look at the administrative cost, the cost of the purchase order itself.
That's a key distinction. I mean, generic purchasing wisdom says buy the cheapest unit, but if it takes 3 days of paperwork and multiple phone calls to chase down small shipments, you've lost any savings.
You've completely negated it. Absolutely. The value of true industrial wholesale is, yes, leveraging buying volume for better pricing. That's the obvious part. But the deeper advantage is in administrative efficiency.
How so?
Offering net terms for qualified accounts and setting up replenishment scheduling.
Walk us through that. Why does a busy procurement manager care about net terms on, a barrel of grease?
Because every single purchase order, every invoice, every payment cycle, that all involves labor. From the maintenance tech who requests it, to the manager approving it, to accounts payable processing it. If you can go from, say, 12 small spot buy orders a year down to 4 large scheduled deliveries on net terms, you have drastically reduced your administrative overhead.
You save time, you consolidate paperwork.
And you eliminate that frantic, high-cost scramble when a barrel suddenly runs dry, which it always does at the worst possible time.
Right.
This is capital preservation, just through smart logistics.
And crucially, the logistics have to support every type of maintenance workflow. The sources were really clear that packaging flexibility is a critical part of workflow efficiency, not just a storage issue.
Packaging is not benign, no. It is entirely about eliminating waste and simplifying inventory control right there on the maintenance floor. If you have a small, isolated motor that only needs a quarterly shot of grease,
you don't want to open a 450-pound drum for that.
Of course not. If you try to transfer from that big drum to some tiny container, you introduce contamination, you waste time, and you almost certainly end up over-lubricating the part.
Okay, that makes sense.
Exactly. And that's why the supply chain has to offer everything. From the smallest 1.75-ounce tubes and grease gun cartridges for those little manual jobs, to intermediate sizes like 16-ounce tubs for bench work, and then up to the bulk scale, the 120-pound quarter drums and the full 450-pound drums.
Which are specifically designed to feed those high-volume automatic lubrication systems we were talking about.
Exactly. Choosing the wrong packaging format is just an open invitation for waste and for error. The supplier has to match the format to the specific lubrication plan.
Let's switch gears now to the non-negotiable side of this. Safety and compliance. It's not enough for the grease to be cheap and effective. It must be auditable, and it has to be safe. This is where that idea of no guesswork allowed really hits home.
It really does. Compliance is the protective layer over the entire operation. It is an absolute requirement that bulk suppliers provide complete technical documentation.
You're talking about safety data sheets, SDS.
Safety data sheets, or SDS, for every single product.
And this isn't just paperwork. This is the key piece of the puzzle that allows an operations manager to verify that the components within the grease are compatible with their machinery and their regulatory environment.
So if I'm in, say, food or pharmaceutical production, I would use the SDS to prove to an auditor that the grease on my packaging line meets FDA standards.
Precisely that. It lets you confirm compatibility with FDA guidelines, with your internal safety protocols, and even with waste disposal procedures. Without that documentation, you are just gambling. Gambling with audits, with fines, and potentially cross-contaminating your entire product.
So the due diligence has to be done up front,
It has to be.
which means buying the right bulk lubricant involves a significant amount of engineering specification.
Yeah.
It's way beyond just a cost comparison.
No, absolutely. The source makes a really powerful claim here. Buying grease is an act of engineering, not a simple checkbox on a shopping list.
I like that. It's true. We're talking about matching the specific NLGI grade consistency to the pump pressure. We're talking about matching the base oil, whether it's mineral or synthetic or food grade, to the operating temperature and the load conditions of that specific machine.
Okay, so let's play that out. What happens practically if the base oil is wrong? Let's say I use a cheaper base oil where I really needed a high-performance synthetic.
Okay. A standard mineral oil base will simply break down. It will degrade under high heat and extreme load conditions.
And then what?
The oil separates from the thickener, the grease thins out, and you lose that critical protective film. And you're right back to metal-on-metal friction.
Right back to that massive amp draw and the eventual catastrophic failure.
Exactly. Conversely, a technical supplier, their whole job is providing the expertise to guide you to the correct high-performance synthetic base oil that will maintain its protective integrity, even if it's running continuously at 400 degrees Fahrenheit.
So it's the supplier's core job to help operations match the right product to the exact requirements, whether that's matching an LGI number 1 for an auto dispenser or choosing the right high-pressure variant for a heavy press.
And that proper specification is the investment that pays dividends. It reduces friction, it demonstrably extends your service intervals, and it fundamentally preserves your capital budgets by protecting your expensive machinery.
It turns a consumable into a preventative engineering tool.
That's the perfect way to put it.
So if the maintenance chief or the procurement manager listening today wants to move from just guessing to actually specifying, the sources gave a pretty clear 3-step pathway.
A very clean pathway to immediate risk reduction. Step 1. Identify the 3 critical factors for your application. That's the bearing type, the required NLGI grade consistency, and the typical operating temperature.
Okay, type, grade, temp.
Step 2. Match that application to the correct lubricant SOQ, and crucially, make sure you select the right packaging format, be it a cartridge or a drum.
And the final step?
Step 3. Contact your wholesale supplier. Get the technical specifications, get a quote, and establish that replenishment schedule to eliminate all the administrative chaos we talked about earlier.
Simple, direct action.
And it immediately translates to lowered risk.
This has been a truly eye-opening deep dive. The takeaway is just so powerful. Proper bulk industrial lubrication fundamentally transforms maintenance from a source of unexpected costs.
The shutdowns, the high amp draw, the expedited freight.
All of it. It transforms it into a source of predictable, calculable profit retention.
The sources really didn't mince words when they summarized this. Buying inferior grease is described as a slow, expensive form of negligence.
Wow.
Conversely, buying the correct lubricant, matching the formulation to the load, ensuring the right packaging from a bulk supplier who provides that technical backing that is defined unequivocally as risk management.
You are buying mechanical uptime and auditable compliance. You're not just buying a tub of grease.
Exactly. And this leaves us with a final thought for you to ponder. If specifying the correct bulk lubricant reduces risk and demonstrably extends service intervals, how many other seemingly small checklist procurement items in heavy industry, items we are tempted to buy for the absolute lowest unit price, are actually misunderstood opportunities?
Are we missing out on fundamental capital preservation simply because we are not paying close enough attention to the technical details of the basics?
That's what we want you to think about until the next deep dive.